Assignment 4-6. I forgot my book. Here we go. Let's look at number 1. Always be prepared at the beginning of your video. Alright. We can do it right here. So, this lesson had to do with volume. And there's different ways you can do volume. So squares, semicircles, rectangles. You could also revolve and make circles. So the base is this region. And if you had squares sticking out, where this is the base of the square, and there's an infinite number of them, what would the volume be? So this is an integration question. We're integrating from 0 to 1. And again, you would do this work in your notebook, not here in the book, textbook. And then a square, the formula is you take the base and square it. And then in this spot is where you go top, subtract bottom. So the top is x squared, the bottom 0, so just x squared take away 0, and there's the setup. For a semicircle, same start. We're integrating from 0 to 1. The formula for a semicircle is pi r squared divided by 2. So we can put it here. You could also put pi over 2. You could put pi over 2 in front of the integration. We're going to learn to do that more. And then inside is the radius. Now, if this was a semicircle, this represents the base of a semicircle or the diameter. The radius is what we want. So we need to take half this value. So top subtract bottom is x squared. That's the diameter, but I have to divide it by 2. And now that's the radius. Rectangles, again, are integrating from 0 to 1. The base of the rectangle, which is top subtract bottom, which is x squared. And the height is 2, so you just multiply it times 2, and you have your answer. Number 2. So it's important to understand this base. Top subtract bottom, so that base is negative x squared plus x, take away 0, which is just that. So that's what we're going to plug in when we do our formula. So again, we're going to go from 0 to 1. The formula is you take the base and you square it. And there it is. For equilateral triangles, the formula is root 3 over 4. And then you take that base and square it. And then rectangles again, root 0 to 1. The base is negative x squared plus x. And then it says the heights are half of the bases. So you take half the base. Another way to see this written is if this was squared. Alright, I'm going to have to do this down here. Number 3. So we have x squared plus y squared equals 4, and the cross sections are perpendicular to the y-axis, and they're squares. I know this is an integration question, so there's the first chunk. I want to graph this. This is a circle. The square root of 4 is the radius, so we count 2 in all directions. So there that is. And then it's perpendicular to the y, so this creates the base right there as we go across. And we're going to go right, subtract left. Now, on the right, I need to solve for x up here. So I'm going to subtract y squared, and I'm going to square root it. Now the answer could be positive or negative. So the right side is the positive, the left side is the negative in terms of it. And we're going to go right, subtract left. Now if I take half of it, so if I just go up to 0, so if I go right, subtract left, and the left is 0, I can then double that answer to make it easier. So on the right is that I'm going to double that so then it goes all the way across. And then the formula for a square is take that and square it. These are going to be y values, so the bottom to the top of the circle. There's number 3 done. Number 4. In number 4, we have y equals 2 subtract x, y equals x squared. And then we have right triangles perpendicular to the x-axis and the base and so on. So first step, this is an integration question, so I'm going to set it up. I'm going to graph this. So we have x squared, and then 2 minus x would mean I start at 2, and then I go down 1 and to the right 1. So this is what it would look like. And this right here is what we're talking about. The base right here would be the base of the triangle. So what's the top of that base and what's the bottom of that base? So the top of that base, subtract the bottom of that base. That represents the base of the right triangle. And so I need to know where we're integrating from, so I need to make them equal to each other to find the bounds. So I'm going to keep the power term positive. I'm going to add x and subtract 2, and then I'm going to factor it. And then the two answers I get here are -2 and +1. And now the formula for a right triangle is half the base, and that's what the base is, times the height. And it says the height is 3 times the base. And there you go. You could also write this as 3/2 in front, and then write this because they're repeated, and you could square it and you could simplify it a bit, but not necessary. All right, number 5. In number 5, find the volume of a solid that's bounded. So y equals the square root of x, y equals 0, x equals 4. So I'm going to graph this. I know this is an integration question, so there it is. And we actually have to do the work here to find the volume. So the square root of x, y equals 0 is right here. And then 4, well, I'll put 4 right here. And so the first step is, how are we finding this volume? They're perpendicular to the x-axis. So these are x's, so it's 0 to 4. They're squares, so this is the formula for square. And then what represents the base of that square is top. So if I drew a base for the square, the top of the base and the bottom of the base would be root x subtract 0. And then actually find it. So the square root of x squared is just x. And then add 1 to the exponent and divide. And then substitute in. So we have 4 squared divided by 2. Plug in 0, the answer is 0. And then this is 16 divided by 2, which is 8. Number 6. In number 6, find the volume of a solid whose base is bounded by y equals 2x, y equals 0, x equals 3, and whose cross-sections are semicircles. So I know this is an integration question. I want to graph this. Doesn't have to be perfect. 2x, up 1 and over 2, y equals 0, and then x equals 3. This is it right here. And it says perpendicular to the x. So there we go. To understand the base, the top of the base, subtract the bottom of it. So that would be 2x minus 0, or 2x. The bounds go from, for the x's, go from 0 to 3. And then these are semicircles. So the formula for a semicircle is pi r squared divided by 2. So I'm going to practice doing this. So pi r squared divided by 2, pi over 2 can be written in front, because I'm going to actually integrate this. It makes it easier that pi over 2 is in front, and then I do the integration, and just at the end I multiply by pi over 2 to make it easier. So the radius is going to be the base divided by 2. See, the base is really the diameter, right? So take the base and divide it by 2. So 2x divided by 2 just gives me x. And this is what I'm going to integrate. So we have x squared. So we have pi over 2. I'm going to add 1 to the exponent and divide. And then I'm going to plug in. So I'm going to plug in 3. So that's 3 cubed divided by 3. Plug in 0 and it's 0. So 27 divided by 3 is 9. So the end answer is 9 pi over 2. Number 7. You get more out of it when you try it first. But if you need support, I'm here one step at a time with you. So for this one, it gives you a graph. This is a semicircle here. It's fine. And they say set up but don't integrate if you revolve it. So here's the region here around the x-axis. So around the x-axis, the top subtract the bottom is actually now the radius. So as you revolve it, this is half, and then it's going to go underneath when it revolves. So this represents actually the radius of the circle. And so the formula is pi, it goes -1 to 1. So it's pi r squared. We don't have to do half of it because this is not the diameter. It goes, when it rotates all the way down, this actually represents the radius. So now, for a revolving question, radius is just top subtract bottom. Because we're revolving, that's the difference. And so the top subtract the bottom. So the top curve, which is square root of 1 minus x squared, subtract the bottom, which is 0, and you have your answer. B. Do the same thing, but revolve it around y equals -1. So let's say y equals -1 is down here. What I want you to notice is this is now a washer question because there's a gap, a space between the area and the line of revolution. So the setup for that is we're going to have a big radius and a small radius, and then we subtract, and what's left over is the volume. So what represents the big radius? I'm just going to continue from here. The top, subtract the bottom. So that would be the square root of 1 minus x squared, subtract -1. And then the small radius, I'll do that right here. So that's the small radius, this is the big radius. Now the top, subtract the bottom, that's 0. So 0 subtract -1, or you could just say 1. And there's the setup. You could also put parentheses around all of it. What number are we at? 8. So they give you a graph. I'm going to still graph it. Kind of this. Not perfect. And one thing that they don't give you are the bounds. So a step here would be to make them equal to each other and solve it. So if I subtract 2x and factor it, I can see that the two bounds are 0 and 2. So it's an integration, 0 to 2. I am revolving, so it's pi r squared. And I'm revolving around the x-axis. See, there's a gap here, right, between the area and the x-axis. So I need 2 radii. And they have the big radius and the small radius. So the big radius goes from the top of the area to what you're revolving around. So that's going to be 2x take away 0. That's the big radius. The small radius, you go up to the bottom of your area, and then what you're revolving around. So what's the top here now and bottom here? So that's x squared take away 0. And there's the setup. B, making sure we're okay. B says, how about the line y equals 5? So that's up here somewhere. So now I need a new representation of what the big radius is. So if I start here all the way through to the bottom of it, the top to the bottom, that's the big radius to the bottom. So that's 5, take away the curve, which is x squared. And then the small radius would be here to here. There it is. So that would be 5 take away the line would be the small radius. And there's the setup. All right, number 9. You are given a graph in number 9, so I'm just going to replicate it here. So to speak. And it says you're revolving this around the y-axis. So because of that, these are all going to be y's. And if you look at the y-axis and the area, there's no gap there. So it's just one circle. And the bottom y value to the top y value. So it says it's from y equals 1 to y equals 4. So those are my bounds, 1 to 4. And then I'm going to go right, subtract left. So the right is y equals 1 over x squared. Now I need to change the way that looks because I need to know what x equals in terms of that. So that's the trick of this. So I'm going to multiply both sides by x squared. Then I'm going to divide by y. And then I'm going to square root it. Now, in calculus, you can leave a square root in the denominator. So when I square root this, the square root of 1 is 1, and the square root of y is y. And it would be positive and negative, but we're only looking at the right side. This graph actually has a left and a right. So we just need the positive value here. And so that's the right subtract left. So it's 1 divided by root y, take away 0, or just 1 over root y. B, revolve it around x equals negative 1. So x equals negative 1 is somewhere here. It starts the same way, but now there's a gap. So now we're going to have 2 circles in terms of y. So the big radius is the curve, and so if you draw the big radius here, so the right subtract the left, so that's the curve, which is 1 over root y, take away negative 1. And then the small radius is this right here, right subtract left. That's the small radius, so on the right is 0, subtract negative 1. That's just 1. And then there's the setup to find the volume. All right, number 10. Turn the page. In number 10, it says, set up but don't integrate, finding the volume of the solids described. So this is a good one because you're not given the graph. You have to do some work, which I like. So I'm going to graph this. 1 divided by x is a reciprocal graph. This is what a reciprocal graph looks like. It also is down here. It's bounded by y equals, so this is 1 over x. This is y equals 0. This is, let's say this is x equals 1. And then let's say this is x equals 4. So it's like this. I want to find the volume by revolving. So first I'm going to revolve around the x-axis. That's what A says. So this area is bounded to the x-axis. There's no space, so it's just one circle. And it's x, so it's dx. And so it goes from 1 to 4. And then top subtract bottom for the radius. That's just 1 over x. Take away 0, or 1 over x. For part B, it says y equals negative 3. That's down below. And again, to represent, there's a space there. So there's going to be 2 circles that we're going to subtract. So we have top subtract bottom. Here's a representation. So that's 1 over x, take away negative 3. That's the big radius. And then the small radius is 0, subtract negative 3. Or just 3. Part C, says, and I'm sorry my camera keeps fuzzing out in this way, y equals 5. So y equals 5, let's say, is up here somewhere. And so the big radius would start up here, down to the bottom. So that would be 5 subtract 0. There's a gap there, right? So 2 of them. So 5 subtract 0, or just 5. And then the small radius would be 5 subtract the curve. So again, 5 subtract the curve would be the small radius. And there's your setup. Boop, there it is. All right, number 11. Step 1 is we're going to graph this. So we have the square root of x. We have x equals 0 and y equals 2. So it's right there. And then it says A, revolve it around the y-axis. So this is bounded to the y, one circle. It's y's. So the bottom y value to the top is 0 to 2. And then it's right, subtract left. So that's, and I need to rewrite this. So I need to see what x equals, so I square both sides. So I square both sides. X is equal to y squared, because this is what I need in here. And there it is. For part B, it says x equals negative 2. So here's x equals negative 2. The big radius from the right to the left. So the curve and negative 2. So there's 2 of them. The curve, which is y squared, subtract a negative 2. And then the small radius would just be from here to here, to the beginning of the area. So that's 0 subtract negative 2, or just 2. In part C, it's x equals 4. So I take the same thing. There's a space there. So there's 2 circles. It's the lighting in the morning that doesn't like this light coming in. I might try to shift over a bit. Try to get away from that to stay focused. Alright, that's a little better. So again, right subtract left. So on the right is 4. And then on the left is 0. So it'd be 4 take away 0. On the right is 4 for the small radius. And on the left is the curve, which is y squared. So practicing right subtract left, the graph, man, you really, really, really have to graph this and visualize it. All right, number 11. We did 11. Number 12. Without using a calculator, find the volume of a solid formed when the region bounded by the cube root of x. X equals 0, y equals 2. So we'll start there. So the cube root looks like this, but also looks like this to the left, but we're not going to worry about the part on the left. X equals 0 and y equals 2. That's the area there. And it says the volume revolved about the x-axis. So if I revolve it around the x-axis, there's a gap there, so it's going to be 2 circles. And it's x's. The smallest x is 0. The biggest x, I actually have to solve for that. So I got to take the cube root of x and make it equal to 2 and solve it. So cube both sides, and you can see that x equals 8. And then the big radius is 2 take away 0, and the small radius is this cube root of x take away 0. And then that would actually be, and you have to find the volume. So there's the setup to begin with. And we just simplify it a bit. So 2 squared is 4. The cube root, so this take away 0 is just the cube root of x squared. To write that together as an exponent, the cube would be on the bottom and the square would be on top. And that's what I'm integrating. So that would be 4x, add 1, so 2 plus 3, and then the reciprocal from 0 to 4, and then plug in 4. Why is it 4? 8. Plug in 8. And then when you plug in 0, the answer is 0. I'm not going to make you simplify that. That's a good answer. The second part, taking the same graph, what happened if I revolve it around the y-axis? Well, around the y-axis, it actually is one circle because it's touching, it's bounded to the y-axis. The y values go 0 to 2, so that's easy. The only tricky part here is I got to change this so it says x equals. So if I cube both sides, x is equal to y cubed. So this curve is y cubed, so if I go right, subtract left, it's y cubed, take away 0, or just y cubed. And that's what I'm going to integrate. So 3 times 2 is y to the 6th. Integrate this, add 1 to the exponent and divide. Plug in 2. 2 to the exponent 7 is 128 over 7. Plug in 0, the answer is 0, so it's 128 pi over 7. All right, number 13. In number 13, sketch the region and use a calculator. So we have f at x equals 2 to the x minus 1. G at x is 2 minus x squared. And so we need to graph that. So this is an exponential that's been moved 1 to the right. This is a parabola that's been shifted up 2 and it folds down. And it says find the volume of that around the x-axis to begin with. So there's a space there, and then it's bounded. So we're going to use our calculator to find the bounds. So we find the bounds by making them equal to each other. So menu algebra, solve, and it's 2 to the exponent x minus 1 equals 2 subtract x squared, comma x. And I get negative 1.3427 and so on, and then 1. I don't know why it's doing that. There. So those are your bounds. So negative 1.3427 is fine, up to 1. When we use your calculator, we'll copy paste in. And then top, subtract the big radius, which is 2 minus x squared, take away 0. The small radius, which is 2 to the x minus 1, take away 0, and then put that in your calculator. So this is what it would look like. I keep moving away from the sun. The sun keeps following me. So I'm going to integrate. Oops. Try it again. I'm going to integrate. I'm going to copy this. And then paste it down here, and then just delete what I want to delete to make it easier. The top bound is 1. And then inside, parentheses, 2 subtract x squared squared, subtract, parentheses, 2 to the exponent x minus 1 squared, and then dx. See if I typed it in right. It should say 16. No, what should it say? Oh, what did I forget? You know what I forgot? I forgot pi. So if you forgot something, highlight over it. It needs to have a pi in front. There you are. There it is. I was looking at the answer key, so I saw it wasn't matching. So it's 16.303. It's now matching. Now it's 3 decimals. Number 14. It says sketch the region, set up integrals for the volumes. So we're not actually going to find the volume. And we have the absolute value of x, y equals 0, x equals negative 2, x equals 3. Equals 0, x equals negative 2, x equals 3. And then it says set up and so on. So we're going to have 2 integrals here, right? Or 1. We could do, I guess we can do with 1. So if I just set it up, because I could use my calculator if I had to. So squares perpendicular to the x-axis is like this. And so when I go top subtract bottom as I go across, it's just the square root of x, or the absolute value of x, subtract 0. That represents the base. We're going to go from negative 2 to 3, the absolute value, and square. Oh, these are squares, so not that. So there's the setup for that, for 14. For B, what are they? Well, semicircles. So again, it's negative 2 to 3. For a semicircle, it is pi r squared divided by 2. And then the base, I have to divide by 2, because the base is the diameter. All right, number 15. Find the areas bounded here. So 2x squared plus 3x, if I factor out an x, 0 and negative 3 over 2 are my x-intercepts. And g at x equals 2, which is like, say this is it, horizontal line at 2. And it says, find the actual areas. So we're going to integrate. Step number 1 is we need to make it equal to each other and solve it to find the bounds. So, quick way, 2x squared, 2x times x is 2x squared. And then I can choose to put 1 first or 2 first. I'm going to make it 1 times 2, and then 1 is positive and 1 is negative so that it fits. So this is 4x, take away 1x, which is 3x, and then negative 2. So the lower bound is 1/2, and the upper bound is negative 2. And top subtract bottom. And then integrate it. So 2 is 2x. This would be 2x cubed divided by 3. This would be negative 3x squared divided by 2. I'm integrating from 1/2 to negative 2, and then the last step is to plug in. You don't have to simplify. Oops, this should say negative 2 to 1/2. You probably saw that. Negative 2 to 1/2. The lower bound to the upper bound. So this should be 1/2. I did that correctly, right? But set this one up wrong. Anyways. And then subtract and then plug in a negative 2. And there's your answer. All right, we're going to graph this by using intercepts. So I factored it. The two y-intercepts are 0 and 2. And it looks like this. 2 minus y. I'm going to change the way that looks to make it easier to graph. I'm going to add y and subtract x. So it starts at 2 and then goes down 1 and to the right 1. So it starts at 2 and goes down 1 and to the right 1. That area is what I want to find. It's going to be right, subtract left. So I need to know the y value. So I know the upper y value is 2. I'm going to make them equal to each other and solve it for the other bound. So y squared minus 2y, 2 subtract y. And we're going to solve that. So you're going to add y and subtract 2, and you're going to factor it. So your two bounds are positive 2, which we knew, and negative 1 is the other one. And then right subtract left. So on the right is 2 minus y. That's the line. And on the left is the curve, which is y squared minus 2y. I'm going to simplify it. So I have negative y squared. When you subtract a negative, you're adding. So negative y plus 2 is positive y, and then 2. And now we're going to integrate. And we're going to plug in. And there's your answer. Number 17. Now some review questions from way back that's important to do. For number 17, y equals 3x cubed minus x plus 1 over x squared. And I want to differentiate. So I'm first going to simplify it. This x squared belongs to every term. So 3x cubed divided by x squared is just 3x. Negative x divided by x squared would be, when you subtract the exponents, would be negative 1. And then 1 over x squared, when you write it calculus friendly, would be plus x to the negative 2. So that when I take the derivative now, it would just be 3 plus x, subtract 1 to the exponent. So you're multiplying, and subtract 1 to the exponent, you're multiplying. Subtract 1 to the exponent, and you have your answer. 18. Gonna write it calculus friendly right away. Uh-oh, I got another one. So to take the derivative here, start with the 10, and then the hook. So the derivative of x and the derivative of x, the 1/2, and you have your answer. Number 19. It's going to be the product rule. Good practice. So the product rule is the first times the derivative of the second. Subtract 1 to the exponent. And then the hook, the derivative of that is the hook, plus the second times the derivative of the first. And there you go. Number 20. This rule is going to be the quotient rule. The quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. Number 21. Antiderivative is integrating. So we're going to integrate x minus 2 squared over the square root of x. So we're going to expand, we're going to expand the numerator. We're going to FOIL it. This is what it would look like if you FOILed it. And write the denominator as x to the half. Then this x to the half belongs to each one. So x squared divided by x to the half, subtract the exponents. Negative 4x divided by that, subtract the exponents. And then 4 over that, the exponent would be negative. So have the algebra skills to simplify them as exponents. And then add 1. And then the reciprocal, add 1, and then the reciprocal, add 1, and then the reciprocal. And then don't forget your children in the back seat. Here we go. Number 22. Same question, the antiderivative. I'm going to write it calculus friendly right away. Oops. I was going to write a calculus friendly. Let's try it again. Let's start here then. So to write this calculus friendly, we're going to write y squared plus 3 to the exponent negative 1/2. The hook comes from inside the parentheses. That hook would be 2y. And so what it was over what it became, so 4 divided by 2, we need a 2 in front. Now you can unhook it. The answer is going to start with 2. And then we're going to add 1 to the exponent, divide or the reciprocal, plus c. (23). We're going to integrate. Again, I'm going to write it calculus friendly. I want you to recognize the derivative of inside the parentheses does not match what's in front. So we can't unhook it that way. We have to do the u substitution. So u is equal to t plus 3, t is equal to u minus 3, and the derivative of t and the derivative of u. Substitute in. T is u subtract 3, t plus 3 is u, and dt is du. And now I'm going to distribute. So u to the negative 1/2 times u to the 1, you add the exponents. U to the negative 1/2 times negative 3, you just multiply them together. And now the antiderivative. So add 1 to the exponent, and then the reciprocal. Add 1 to the exponent and the reciprocal, and then your children. And then at the last step, plug t back in. So it's t plus 3 is u. And you did the antiderivative. All right, 24. Turn the page. Last page of your homework. A Riemann sum. Remember that? So he gives you a graph even, so that's nice. So how many rectangles? And it's a midpoint. So step 1 is to find the width. So that's the top, subtract the bottom, divided by how many you have. So the width of each one is 2. And so to estimate this integration, we're going to start with 2. And then the width is 4. So from 0 to 4, the mid one is... Sorry, the width is 2. Haha. So from 0 to 2, the middle is 1. So the first height is 10. Then the next height is 2. Then the next height is 5 at 5, and then the last height, which is at 7. And so you use the middle values of the rectangle, use the heights, and there it is. Do a left hand Riemann sum, same number, so the width is still 2. But what would left mean? So from 0 to 2, use the left one. So 0 is on the left, so we start with 17. Sorry, 0 to 1, from 2 to 4 is the next one. We use 2. So if I plug in 2 squared minus 16, that's 1 plus 5, it's 5. Does that make sense? Yeah, 5. And then from 4 to 6, it's here at 4. So that's 16 and 17. That's negative, that's 1. Just double checking. I know it looked like 1. From 6 to 8, we use 5 again. And those are your rectangle heights. That's a Riemann sum. For 26, says use a Riemann sum with 3 inscribed rectangles of equal width. So inscribed means a lower one or an upper one. So an inscribed means a lower one. So if I did a lower one, and it's 0 to 9, it says, with 3 of them, so the width would be 9 divided by, there's 3 rectangles. And so the first rectangle, the height would be 2, I mean. The next one, 3 to 6, it would still be that one from 3 to 6, the lowest one. No, sorry, from 3 to 6, the next lowest height would be 1. And then from 6 to 9, 9's way up here. So from 6 to 9, 6 would be the lowest value, which would be 5. And so why is that such a poor estimate? Well, look how low the rectangles are. So this is such a poor approximation because under the curve is far larger. So the area under the curve is far larger than what this is. So if you had like this, and then you had this, and then you had this, I mean, that's all you're covering, right, in terms of it. And how much are you not covering? So it's a really bad estimation because there's far more area that's not being covered by doing a low Riemann sum. All right, 27. This is what's called a fundamental thermocalculus question. The derivative and the integration undo each other. We're just substituting it. Don't worry about the trig. It's just a plug-in question. So what do I plug in first? And then the derivative of x would give you the hook. I don't need it, but it's there. Subtract. Plug in the lower bound. This one does have a hook. from the limit, from the bound. So the derivative of x cubed gives you a hook 3x squared. That's the fundamental theorem of calculus. Number 28. Show an integral setup for the average density of hikers. So that's like average value. And so that's an integration question. And from 1 to 5 miles means we integrate from 1 to 5 the function, which is this. And then you divide by the difference of the bounds. So that would be the setup. Number 29, use a midpoint Riemann sum with n equals 2. So we have the same average. So from 1 to 5. So the difference of the bounds divided by how many you have. So each one's going to be, the width is 2. And then a midpoint, we go 1 to 3, and the middle would be the 2 value. So 35. And then 3 to 5, and the mid value would be 25. This is what? 50, 60 times 2. It's 120. And then if you take that area to approximate it, you take 120 divided by 4. And so approximately how many hikers are there? So the average density is 30 hikers per mile. It's not that there's 30 hikers. In fact, there's 120 hikers in there. But the average is 30 hikers per mile. 30. Use a 4 equal width trapezoids to do it. So on the same interval. So it's 5 take away 1 divided by 4. So the upper bound, this is what I'm approximating. So the upper bound subtract the lower bound by how many you have. So each width is 1. The formula for a trapezoid is 1/2 times that, and then the heights. So we have 40, double 35, double 30, double 25, and then 20. And then I divide that by the difference of the bounds. So again, I'm trying to find the average to do that. The answer is still 30. So this answer is still 120 divided by 4. I guess you'll trust me on that. And then 31. Estimate where on the trail the density of the hikers is equal to the same average density. So when I think of 30, right here is 30. Okay, where would it be? And so about at 3, the average is equal to the density right there. Just looking off the graph. And I just drew a line from the trailhead. 32. Write a complete sentence using numbers and units to tell what that integration means. So from 1 mile to 5 miles from the trailhead, there are approximately 120 hikers. And then 30, 33, last one. We can get there. Man, we got it. The derivative is sine x squared. If f at 0 equals 2, find f at 3. You ready? This is a starting value problem. So I want to find f at 3. So the starting value is 2. And then I integrate from 0 to what I'm looking for, which is 3, and I integrate the derivative. you're going to use your calculator. So type this in your calculator. I don't know where did mine go? Here it is. And the answer is about 3.569. You don't have to round. Done. Over. Mr. G Math, over and out. I'm really proud of you. You finished your work. Till next time.